Okay, students, welcome to 7.3, Law of Cosines. Note when given cases SSS or SAS in an oblique triangle, we can use the law of cosines to solve the triangle. Law of cosines, in any triangle ABC, besides A, B, and C, the following holds. C squared is equal to A squared plus B squared minus 2AB cosine C. So if we look at the only angle that we're talking about here, that's this angle here, C. And the A and B in the formula are the adjacent sides to that angle. And the C that we'd be solving for is the opposite side. Now, it doesn't really matter what the A's and B's and C's are, how they're oriented, but the relationship holds. So if I wanted to solve for angle or side B, I would just swap out A and C. The included angle here would be B, and A and C would be the adjacent sides. And so it would be A squared plus C squared minus 2AC cosine B. And if I wanted to solve for side A, it would be A squared equals B squared plus C squared minus 2BC cosine C. Okay, so it really depends on what you're given. Which angle depends on which formula here. But again, you only need to memorize one formula because they're basically all the same due to symmetry. Okay. Okay, solve triangle ABC if solve triangle ABC if A is 28.2 feet. So A, B, C. C is 46.7. And angle B is 73.5. Okay, so in this case, the included angle is B, and the side that we're looking for opposite that is side B. Okay. So we're going to use the second formula here. B squared equals A squared plus C squared minus 2AC cosine B. We find out what side B is. We can't use the law of sines because we don't have two sides or two angles opposite each other. Okay, we only have the one angle, and so we can't use law of sines. And the one angle is not opposite a side that we know. If we knew what angle B was, then we could use the law of sines. I mean, if we knew what side B was, we could use the law of sines, but we can't in this case. So B squared is equal to 28.2 squared plus 46.7 squared minus 2 times 28.2 times 46.7 times the cosine of 73.5. Okay, so B squared is equal to, okay, some value. Let's plug that into the calculator here. 28.2 squared plus 46.7 squared minus 2 times the same two values, 28.2 times 46.7 times the cosine of 73.5 degrees. Okay, and I get about 2228.06, and this is supposed to be the angle of a side. So why is this such a big number? Well, it's because it's being squared. Remember, this number here that we got was B squared. So B squared was about 2228. We'll say 0.1. If I square root that, then I get a side B. Let's just square root the answer here. Second square root, second minus sign. Okay, it's about 47.2 feet. That's a little bit better. Makes a little bit more sense. So 47.2 feet. Okay, so we have side B there, which is nice. So now that we know a side and an angle pair, we have a side and angle pair. This B was 47.2 feet. We have a side angle pair. Now we can use law of sines to solve the rest of the triangle. We couldn't before, but now we can. So if I do say let's try to figure out what A is here. Okay, if we do sine A over A is equal to sine C over C, or I'm sorry, sine B over B, B over B, because what's what we have? We have the angle side pair of that. So we know what A is, so I'm going to multiply both sides by A. This is A over B sine B. Okay, so the sine of A is equal to A over B. So A is 28.2 and B is 47.2, what we just found. And then the sine of angle B, which they gave us, was 73.5. So now we have the sine of A is going to be approximately equal to this value. However, we're going to have to take the inverse sine of that value in order to get a couple of angles. So we're going to take 28.2 divided by 47.2 times the sine of 73.5. Okay, that's 0.5729, I'll say. 0.5729 about. So 0.5729. And now A is approximately what? Inverse sine of my answer is 34.95 degrees, I'll say. It's pretty close to 0.0, but I won't round to the nearest tenth because it's right in the middle. 34 point, oops, that looks like a 9. 34.95 degrees. That's angle A. Now, could there have been another angle A here? Well, certainly there could have. Okay, if I take 180 minus this angle, because the sine values are positive in both the first and second quadrants. So if I use a reference angle of 34.95 in the first, I could have another angle in the second. So 180 minus 34.95 is equal to what? 180 minus this answer is 145.05. 145.05. However, what happens when I take the existing angle we know, which we were given? We can't. That's not a variable. That's a constant angle, 73.75, and we add that to the other obtuse angle for our obtuse triangle here. Well, 145 plus 73, that's way above 200. And so since this is way above 200, and you can only have 180 degrees in a triangle, this cannot happen. Okay, you cannot. So there's only one triangle exists here. Okay, and so angle B was equal to 73.5. Angle A is 34.95. So what would angle C be? That's the only thing that we don't have now is angle C. So, well, we can get that by subtracting the other two angles. Angle A ended up being 34.95. This angle was 34.95. And so we can use the fact that the sum of the angles in a triangle are 180. And so this is 180 minus 34.95 minus 73.5 is equal to angle, what are we looking for? Angle C. Okay, and so 180 minus 34.95 minus 73.5 is 71.55 degrees. And that's what C is, 71.55 degrees. So A is equal to C. Okay, angle C. So we found all three sides, all three angles, using the law of cosines. Now, what happens if we just have SSS here. Okay, example 8 is an example of side, side, side. We just have 3 sides, no angles. But we can still find the angles using law of cosines first and then using law of sines after that. So we have a triangle, okay, ABC. Oops. Okay, and side C is 59.3. Well, let's do A first. A is 25.4. B, opposite B, is 42.8. Opposite C is 59.3. Oops. 59.3. Okay, so we can use the original formula to solve. We can choose which angle we want to solve for. Okay. Oh, this was an A. Sorry. That was an A. We can choose which angle we want to solve for. So let's just solve for angle C since it's the first formula here. Okay, so we go C squared equals A squared plus B squared minus 2AB cosine C. So we're going to solve for this guy here, cosine C. So, oops. So C squared equals A squared plus B squared. This is 59.3 squared is equal to 25.4 squared plus 42.8 squared minus 2 times A, which is 25.4 times B, which is 42.8 times cosine C. Okay, so now I'm going to toss these two to the other side and then divide by the bottom here. So I'm going to do that all in one step. Hopefully you don't get confused. 25.4 squared minus 42.8 squared all over 2.8 times the cosine C all over negative 2 times 25.4, 42.8, negative 2 times 25.4 times 42.8, and this cancels, which is what I want, and this will equal cosine C at the end. Do this, raise it up so I have a little bit more room left. Cosine C. Okay, so let's see what cosine C ends up being about. Okay, it's going to be a negative value, I'm pretty sure, but let's plug that all into the calculator. So we get 59.3 squared minus, and you can put parentheses on this if you want. I'm going to do it in, I would do it in stages myself, or I wouldn't need parentheses, but I'll do parentheses. 59.3 squared minus 25.4 squared minus 42.8 squared. Okay, close parentheses, divided by parentheses, negative 2 times 25.4 times 42.8. Okay, and that gives me about 0.4 4781, negative 0.4781, yeah. So negative 0.4781. Now I have to take the inverse cosine of this. Okay, so C is going to be equal to the inverse cosine. Okay, and keep in mind this is an angle C that we're finding. Okay, inverse cosine of this, second inverse cosine of my answer gives me 118.56 degrees. I'll just round that to 118.6 degrees. Oops. Okay, so this is 100, go back. Okay, this is 118.6 degrees is angle C. Now that we have an angle and a side pair, Also, this angle is obtuse. Notice that. That's an obtuse angle, which means there's only one triangle here. Okay, and angle C is the obtuse triangle. So my triangle is not really, doesn't look to scale. I could change that if I wanted to. Okay, I could very much easily make angle C an obtuse triangle. Okay, C, B, A. Okay, where this is now 118.6 degrees. Okay, so, and side C, which kind of makes sense. Side C is the longest side, and it's going to be opposite the longest angle. So this is 59.3. This was 25.4. And B is 42.8. So angle A should be opposite the smallest side. So angle A should be the smallest angle, and angle B should be the middle angle. So that's good. Okay, so let's solve for angle A now. Let's solve for the smallest angle. So we can use now law of sine. Sine C over C is equal to sine A over A. Okay, because we now want to solve for angle A. Okay. Okay, so the sine of C, sine of 118.6. Okay, all over C, side C, which is 59.3, is equal to sine A all over side A, which is 25.4. Multiply both sides by 25.4. Okay, and we get the sine of A would be approximately what? So this is going to be 25.4 divided by, oops, no, this is going to be A divided by C divided by 59.3 times the sine of C, which we just figured out was 118.6. And that's about 0.3761. 0.3761. Okay. So 0.3761. So what would A be? A is approximately what? Well, let's take the inverse sine of that number. Second inverse sine of point of the answer here we got. And that's 22.1. Yeah, 22.1 degrees. 3761. Okay, and that's 22.1 degrees. Okay, so A is 22.1 degrees. Now, how are we going to find angle B? Well, that's easy. It's just those, all the angles have to. Now, also, are there two triangles here? Do I have to figure out what the other angle A is? No, because it's obtuse. Okay, A has to be an acute angle. You can't have two obtuse angles in a triangle. Otherwise it looks like this, and it's not a triangle. You'll never get a triangle if you have two obtuse angles. So we know that 22.1 degrees is locked in as angle A there. Okay, so now just to find angle B, we just subtract 180. So B is 180 minus 118.6 minus 22.1. Oh, okay. So 180 minus 118.6 minus 22.1 is 39.3. Okay, so 39.3 degrees. I want to update my notes here. good. Okay, so 39.3 degrees is B. 39.3 degrees, perfect. Okay, let's look at Heron's formula. Okay, the area of any triangle is given by square root of s times s minus a times s minus b times s minus c. This is a way of getting an area if you only know the sides, okay, of a triangle. And it's based on something called the semi-perimeter. And the semi-perimeter is basically the perimeter. We just add up the sides that were given and we divide by 1/2. Okay, and that's called the semi-perimeter of the triangle. Okay, so the first thing that we always calculate is the semi-perimeter. So S is equal to 1/2 times A. A is opposite angle A, is side A, so that's 599 plus opposite B is 834 plus 262. Okay, so this is going to be plugging into the calculator. I'm going to clear this. I'm going to say that we have 599 plus, or I could do the 1/2 as well. 1 divided by 2 times parentheses 599 plus 834 plus 262 equals 847.5. So that's S. That's the semi-perimeter. 847.5. That's the semi-perimeter. Now we just plug this into the formula. We have A, B, C, and S. So the area is just the square root of S, which is 847.5, times S minus A, which is 847.5 minus 599, times 847.5 minus B, which is 834, times 847.5, 47.5, minus 262. All of that is under the square root. So A is equal to 847.5 times 847.5 minus 599. 847.5 minus 599 is 248.5. So 248.5. 847.5, 847.5 minus 834 is 13.5. And 847.5 minus 262 is 585.5. This is 585.5. So plug that all into the calculator, and I get the square root of 847.5 times 248.5. It's nice, all the numbers are on my screen. Times 13.5 times 585.5, and I get about 40,000 square feet. Okay, which makes sense because this is square feet, it's not just feet. So A is about 40,800 square feet. That's the area. My 40 is off. Okay. Okay, and that's 7.3, and I will see you in the next video.